So molarity is equal to the moles of the solute per the liter of solution. But most of the time you'll just see it represented this way, where you've got the molarity, and that's going to be equal to the moles per the liter that's there. So what then can we do to change the molarity? Well, we can obviously either change the moles or the liters, or both, I suppose. But let me give you an example of one of the more common things that you're going to have to do in chemistry, and that is to dilute a solution of an already concentrated solution into a more dilute solution.
So check this out. Here is a sample of a cobalt nitrate substance. So there is some atoms and molecules kind of there. That's going to be a certain number of moles, whatever those number of moles are. It really doesn't matter for the purposes of this discussion. Now, if I want to go make a solution out of that, then all I have to do is add that into a beaker, like so, and then add in some water to that. So here is some water, like so. And now I have made a solution of that. Now I'm going to stir this and be right back. I have now stirred that to the point where I have made a proper solution out of that. Now remember, there are still the same number of moles in there as were before. I've just combined it with some water in order to make a solution out of it. And you can see it's a fairly dark red solution. But what if I were to take that whole thing and put it into a larger container here, like so, and then take that larger container and add a whole bunch of water to that. So again, I now have a different solution. It's a considerably lighter solution than it was before. But remember, the same amount of red material, the cobalt nitrate that was there, is still in there. That hasn't changed. So the moles have stayed the same. Even if I were to take this whole thing and put it into another container. So now this whole thing is in an even bigger container, like so. And again, if I just add more water, I am making this less and less and less concentrated, more and more and more dilute, but the number of moles that are present in this has not changed. So the moles are equal.
So if the moles are the factor that hasn't changed in our equation, then let's solve this equation for the moles. Here are the moles, and currently the moles are being divided by the liters. But if we take a moment and just multiply this right side by the liters so that they cancel, but anything I do to the right side I have to do to the left side, so I have to do the molarity times the liters, then what you do is you end up with an equation that looks like this, that the molarity times the liters is equal to the moles. And remember, the moles before are the same as the moles after. And the only thing that's really changed is the amount of liquid, the amount of solvent in the solution, and therefore the concentration. So in reality, there's going to be a new molarity and a new liters that are there, but it's still going to be the same number of moles. So rather than have a 4-series, equation like this, we're just going to cut out the middleman because everything is the same anyway. So if we cut out the middleman, then what we get is this equation here. So the molarity times the liters before is going to be the same as the molarity times the liter after, because both of these guys give you the same number of moles of the solute that is there. Now, rather than do before and after and all that kind of stuff, what we typically do is we do 1s and 2s instead. So 1, 1, and 2, and 2, just a little bit easier. And it also works with things that aren't liters. You could use milliliters, you could use cups or gallons, as long as you keep it the same. You can't use cups on one and gallons on the other. You can't use liters on one and milliliters on the other. So we're just going to make it a generic volume set for this, and ultimately then what we end up with is the equation M1V1 equals M2V2. And that is our equation that we will ultimately use. So how do you use this equation? It's quite simple. All you're going to do is do M1V1 equals M2V2. And provided both of your concentrations are in molarities and both of your volumes are the same, it doesn't even matter what that volume is, like in this case it's milliliters and milliliters, you're fine. If one of them was milliliters and one of them was liters, you couldn't do it. If one of them was liters and one of them was cups, you couldn't do it. But if one is gallon and the other is gallon, it's fine. It doesn't matter what the volume is for this particular equation. So all you're going to do is plug everything into your equation. So you just have to identify which is which. So you've got 14 milliliters. I'm going to call that V1. Why? Because it's the first volume that I saw. And clearly that V1 is with that 12, which is going to be my M1 that is there. So we're going to have 12 molarity times 14 milliliters. All right. And then we're going to have our second set. And our second set, this guy here is 88 milliliters, so that's clearly V2. And then it says, what is the new concentration? So that's M2, and that's going to be equal to X. So now we're going to come over here, and we're going to say that M2 is my X, and V2 is my 88 milliliters. So all I have to do now is solve for X. So this is a simple algebraic situation. Divide this by 88 and divide this by 88. And you end up then with your X being equal to about 1.91 molarity there as your answer for that guy. So number 2 here is no different than the other ones. We're going to have a dilution problem, so it's an M1V1 equals M2V2 kind of a situation. So let's go through and identify what's what. This guy here is clearly my V1 because it's the first one that I saw, and that's clearly my M1. So coming down here, that's going to be 0.25 molarity times my 36 milliliters. And then that is going to be equal to my M2 here, which is what they gave me. And it wants to know what the new volume of the solution is. So that's my V2, which is clearly my X then. So this is going to be 0.10 times X. So solve for X, divide this guy by 0.10, divide this guy by 0.10, and you should end up with X being equal to 90 milliliters.